Okay, so we're gonna redo 8.1. Awesome. Are we cool with what a vector versus scalar is?
Yeah.
Okay. A vector literally has a direction, so that's why a vector, you'll notice literally this arrow, a vector has magnitude, length, and direction. So a vector has to have an arrow, has to have a direction associated with it. So a vector is a quantity that has both magnitude and direction, so you should have already had this filled out, so we're good. Examples include velocity and force. Right, so velocity, if you're saying you're going 60 miles an hour, that's a speed. That's how fast you're going. It's not telling you where, right? If I'm saying I'm running, but I'm not running in the right direction towards the finish line, that's dumb. So I have to have a direction associated with it, right? Vectors have a direction. A force, okay. Velocity, force, all right. Let's say Sarah and I go to the park. That's sketchy. She goes swinging. She wants me to push her. Cool. So ready? I exert a force. I push her, but then like, wait, which direction am I pushing her? Right? Normally swings, you should push them back and forth. If I push her to the side, that's not what she wants, right? Force has to have a direction associated with it. Which direction are you actually pushing? A quantity that only has magnitude and no direction is a scalar. So if you hop on a scale, it'll tell you a number. It's not going to tell you a direction. It tells you a number. Oh, this many pounds, this many kilograms. Secretly, a scale tells you like the pull of gravity on you. So mass versus weight is very different. Because if you go to Jupiter, you're going to weigh much, much more. Because there's a higher force of gravity pulling you much stronger. But your mass, amount of kilograms that make you up, it doesn't change. So a scalar, scale, it tells you just a number. So if we say the velocity of a certain object is 60 miles per hour east. Or yesterday, apparently, the person who won it, 2 hours and like 8 minutes, 4 minutes or something. Crazy to do 26 miles. That's crazy. So he was going on average, I want to say like 4.5 minutes. Definitely breaking the 5-minute mile for 2 hours straight. Which direction was he running? West. He was going super fast. 13 miles per hour west. 13 miles per hour is your magnitude. West is your direction. All right. So a ball thrown northwest at 60 meters per second. Oh, you literally have a direction northwest and you have a magnitude. So I'm going to like talk through this until we hit the point where we're like confused. A tennis ball. So this is a vector. A tennis ball served 110 miles per hour. It's not saying if you're serving at the ref, if you're serving at the crowd, like where are you serving? Oh, to the other person? Good. You know, serve at the ref. So we don't know. This is a scalar. I didn't tell you where it's going. A sprinter running 100 meters north. This is a vector because you have the magnitude, the number, which is 100, and you have the direction, which is north. Okay, so vectors are represented as an arrow diagram or a directed line segment. It's just not just a line segment. Literally one end has a point to it, has an arrow to it. So look at this arrow. So the way we name it, we go from A to B, but it's not line segment A to B. It's a vector. So you have this little like arrow-ish thing at the end right here. So you're going from A to B. And the direction, we just said vectors have direction. Direction's important. You're going from A to B. So you're going from the tail to the tip. The tip is where you have the arrow. The tail, it's almost like you have a like a bow and arrow. The tail is like the little where the feathers are. Okay, good so far? Questions? Okay. So there's a couple different ways to write it. You could have like a bolded letter. Right? This is vector A. It's really hard for me to distinguish an A versus a bolded A. You don't want me to be artistic. No, thank you. So another way we do it in like physics, if you just have a bar over it or the little arrow, that will say vector. Most likely I'm going to say like vector A, that way. So the initial point is the tail, the terminal where you end is the head, it's the tip of your vector. It's where the arrow is. So vectors in standard position have its initial point at the origin, right? This is just like chapter 4 when we were drawing angles. We started at the origin and then we go around. Cool. So we start at the origin and then we go around this way. The direction is the angle between the vector and the horizontal line. The magnitude is going to be the length of the segment, and the way you say magnitude is basically you're taking the absolute value of your vector, because we don't care what direction it is. The direction gives us negative or positive. Magnitude is just the number. So right now I am 10 feet to the right of Bradley. I am positive 10 feet, right? My magnitude's 10. Jake is also 10 feet from Bradley, but he's negative 10 is the direction, but he's still 10 away. So magnitude is going to be positive because it's saying how far away, how long is your vector, right? I'm 10 feet away, Jake's 10 feet away. Difference is direction. He is the negative direction to the left. I'm the positive direction to the right. Okay. That's why we have absolute magnitude, because it takes away the negative, wipes it out, and so therefore we neglect the direction. All right, in the vector above, 1 centimeter is 5 feet per second. Okay, so if you measure this on your paper, you would find it's 2.6 centimeters, right? This length is 2.6 centimeters. So if 1 centimeter is 5 feet per second, 5 times 2.6 will be 13 feet per second. That will be the magnitude of this vector. If 1 centimeter represents 2.5, and we have 2.6, that means it's actually going to be 13 is what it represents. And so if I want to make this, if I want to write this as a vector, I could say 13 feet per second at 35 degrees above the horizon. So this length is 2.6 right here. 2.6 centimeters. Every centimeter represents 5 feet per second. So 5 times 2.6 is 13. All right, so that's standard position bearing. Oops. Yeah. Normally when I make screencasts, like if I have to do it next week or whatever, Lord forbid, I'll make sure I do it in the morning when I'm awake. And I'll make sure to actually like take my time to explain it. Okay, ready? Bearing. This is another way to express direction. All right, so the direction of a vector is sometimes expressed as a bearing. All right, a quadrant bearing, phi, that's what this little guy is right here, right? This is, scroll over, this is a phi. That's all it is. It's a Greek letter. Pi is a Greek letter. Rho for density, that's a Greek letter. Phi is another one. It's another way to say an angle. Normally we say theta for an angle, that's a Greek letter, but here we're saying phi. It's kind of like you draw a number 9, except you just go in the middle. It's like go in the middle, that's phi. All right, phi is a directional measurement between 0 and 90 degrees east or west of the north-south line. So maybe you've like watched a TV show or a movie, it's like, 0909er, we're at a bearing of 15 degrees west or whatever. That's what they're talking about. 15 degrees west from the north-south bearing. Okay, quadrant bearing of this vector example is 35 degrees east of south, or south 35 degrees east. Yeah, blah. It is something your book talks about, especially with planes. If you are a true bearing versus a normal bearing that you hear, the true bearing, you're measured from north and going in a clockwise direction. So if I have a bearing of a true bearing of 145 degrees, that's going to be a quadrant bearing of 35 degrees. So we would be a bearing of 145 degrees, a true bearing of 145 degrees is the same thing as saying a 35 degrees east of south bearing, because you're 35 degrees east of the south point. Yeah. It gets confusing pretty fast. All right. Okay. Now we're going to talk about these vectors. So I'm going to try to make sure, I'm going to really try to focus on the important things that you like see across the board in physics and engineering, etc. So look at all these vectors I have, right? A, B, C, D, E, F. Parallel vectors are the same or opposite direction. Literally, they won't ever like cross. They're going the same direction. So railroad track. There are two tracks. They are parallel to each other. They will never touch. So if you look at all these vectors, there are a bunch that are parallel to each other. A, B, C, E, F. These are all parallel to each other. So parallel vectors, they have the same slope, but not necessarily the same magnitude. They may be parallel, but different lengths. So if I had everyone stand up and point up, right, we would all be parallel vectors because look, we have a direction, right, pointing up. You have a magnitude, your height. Difference is everyone's magnitude is not the same. We have people who are taller, people that are shorter, different lengths, still parallel vectors. So same slope, and then the same, and not necessarily the same magnitude. So talking about magnitude is length. So the parallel vectors in the diagram above are going to be, let's see, A is parallel to B, which is parallel to C, which is parallel to E, which is parallel to vector F. Notice I'm drawing a little vector arrow on top of all of these. I'm also drawing the little train track parallel symbol from geometry, saying these are all parallel to each other. Parallel vectors. Now, equivalent vectors, same magnitude, same direction, cookie cutter, amazing, exact same thing. So the equivalent vectors are going to be, let's see, A is the same length as C. And remember, equivalent vectors have to be same magnitude and the same direction. Why is E not one of my parallel vectors? Opposite direction. Awesome. Okay. So, equivalent vectors, same magnitude, so that's the same length, and same direction. So A is going to be equal to vector C because they're equivalent, so they're equal. Opposite vectors, same magnitude, but opposite direction. So A and E, right? A and E, these are opposite because they're going the opposite direction. So vector E is the same as negative of A. Also, you could say, right, vector C is the same thing as negative vector E. Because if you add them together, they should equal 0. If we add vector A plus negative vector A, that has to equal 0. It's kind of like adding 5 and negative 5. They're exactly opposite in magnitude numbers, so they cancel each other out. When we add opposite vectors, you get a 0 vector, literally a length of 0. Cancel out. 2 pages done. How are we feeling? Questions so far? Smoothing away any cobwebs of doubt. Okay. Resultant vectors. So when 2 or more vectors are added, their sum is a resultant. There are 2 methods to find resultant vectors, the triangle method or the parallelogram method. Now the triangle method is tip to tail. So you take the tip of vector A and you put the tail, right, of this vector B. You move the tail over. Oh my God. Move the tail over, and here's my B. So the resultant would be going from the very, very end point to the very, very start to very, very end. This would be your resultant. Tip to tail method. It literally tells you what to do. Now the parallelogram method, I don't like. I think it's unnecessary. Still have to teach you. So you go tail to tail, and then trace out, complete the parallelogram, trace out, so that way you have all 4 sides. And the resultant, you connect the diagonal to your resultant. Like, why? Why not just do tip to tail? Whatever. Cool. I don't like parallelogram method. I don't like tail to tail. It's more useful to do tip to tail, because if you take physics in college, this is what they're going to say. Okay. So, triangle method, tip to tail. As long as you understand what a tip of a vector is versus a tail, you should be groovy. So let's find the resultant of each pair of vectors using either the triangle or parallelogram method. State the magnitude to the nearest centimeter and direction relative to the horizontal. Okay. So, I think you're supposed to like have a protractor and a ruler. I don't, on your test and quiz, I don't have you like use those as juvenile. Like you did that in geometry, so I'm not gonna have you do that again. So, what you want to do is you want to measure out V, and we're trying to do V plus W. So try to make V the same length as what was on the left side. And then my W is this long. Okay. Notice how I'm doing tip to tail. All right, the tip of vector V. I put the tail of W. Cool. Now that I have those two, I can connect them, and here's my resultant. I'm going from where I started to where I ended, and this is going to be my resultant. So if you measure your resultant, you'll see it's 3 centimeters. And if you find the angle between the horizontal and your resultant, that's going to be 60 degrees. If you measured it with a protractor. So I'm going to break it down how to mathematically do this later. Because I give you numbers for V and W. I'm not going to have you do it that way. The way I'm going to have you do it, I'll give you how long V is at what angle. I'll tell you how long W is at what angle. You break both these vectors into its X and Y components. You add the two X components together, you add the Y components together, and then you make a new triangle. So my hope is to be able to do at least one of your homework problems together today. Question?
What does it mean when it's like V is north of west?
Where does it say that?
It doesn't even know why.
Okay, so I'm going to answer homework questions later. I'm going to finish the actual things now. Okay. All right, so now I have vector A and vector negative A. These are opposite vectors, so what will they sum to? They'll add to 0. So opposite vectors, all right, vector A plus negative vector A is going to be 0. It's a 0 vector, literally a length of 0. All right, multiplying vectors by a scalar. All of this was on, like I know this is part of your ALEKS because a lot of people, it helped people with this before. So for example, okay, so multiplying by a scalar. All you do is you multiply the magnitude. So A versus 3A, it's just 3 times the length. Still the same direction. If I take A and multiply by negative 3A, guess what happens? This is negative 3A. The negative changes direction. The negative literally causes it to rotate 180 degrees, opposite direction. So multiplying by a scalar, you just multiply the magnitude. All right, so let's draw a vector diagram for the next part. So I want 3 times x. So that's going to be 3 times this length x. Let's see, so if that's 1x, here's 1, 2, 3. And then I'm subtracting 3/4 y. So 3/4 y is going to be about that long, except we have to flip it. So it's going to be, oops, come on. Flip direction, and this is negative 3/4 y. So I'll bring that down here, tip to tail. Here's 3x, here's negative 3/4 y. And to find the resultant, you go from where you started to where you end. So this is my resultant vector. And that's all I wanted was a vector diagram. That's it. So this is my resultant. Questions how to draw it, it's just tip to tail. So Andrew, if you come up with the problem, the homework problem, we will have time to do it. So this is where the real, like, now that was the basic, that was the foundation. Now is where we're actually going to start getting to the numbers, where it's going to be very similar to how I asked you to do on the quiz and test. So vector components. Vectors which add to create a vector R are called the components of R. When working with vectors, it's most useful to resolve a vector into its rectangular components, which is the horizontal and the vertical. Horizontal is your X, vertical is your Y. All right. Here's where the fun begins. Okay, so example 3. While digging in his garden, Daniel pushes a shovel into the ground with a force of 680 newtons. Right? At an angle of 70 degrees with the ground, draw a diagram that shows the resolution of the force Daniel exerts into the rectangular components. Make it more interesting by having your name in it. Okay. So, you're pushing a shovel into the ground at an angle of 70 degrees with the ground. So throw back to chapter 4. So it is an angle of elevation. So here is my angle of 70 degrees. All right, why is my arrow going down? Why is it going down? Okay, you're pushing the shovel down. You're putting it into the ground. So this is at a force of 630 newtons. Was this on the screencast? I do not remember talking about this in the last 48 hours. Good to know. No recollection. Okay. Ooh, okay. So, we drew our vector. We need to break it into the X and Y components, the rectangular components. This is probably why you're confused. Alright, so I have the X. This is going to be the force in the X direction. This is going to be the force in the Y direction. And remember, this is a triangle. I'm going to make it a right triangle. Do you have skills in your math toolbox to find the X and Y components? Yes. What shall we use? Sine and cosine. SOHCAHTOA. Okay. SOHCAHTOA. Alright, so, I'll draw a diagram. That was it for A. My bad. B, find the magnitude. Okay. So, if I take sine of 70 degrees, sine is opposite over hypotenuse. So my force in the Y direction is going to be 630 times sine of 70 degrees. And if I want the horizontal is the adjacent side, so I say cosine of 70 degrees is going to be my force horizontal over 630. So 630 times cosine 70 degrees. You need to make sure your calculator is in what mode? Degree mode. What mode? Degree mode. Okay, you got to make sure you're doing it properly. 215.47 newtons. I'll leave this up for another moment or so. Are you okay? Yeah? Okay, just make sure you write down things. Perfect. Now we have like 20 minutes where we can go over homework problems. Questions over the notes before homework? Perfect. Okay. Okay. Yeah.
Does it matter when you draw the triangle? Like
It does matter the way you draw the triangle. I'm confused what you're asking right now. So for this first one, you're talking about the first homework problem? So, okay, I have this open. Page 3. Okay? So, yes, because it will tell you V plus W or W plus V.
And how do you know, because you put W here and V there, but how do you know?
So, in the problems, it will tell you the order it wants you to add. The homework will tell you the order it wants you to add. I'm gonna go through it together. It's all good. All right, grocery shopping. Hannah walks 45 degrees north of west for 1,000 feet, and then walks 200 feet north to go grocery shopping. How far and what north of west quadrant bearing is Hannah from her apartment? You gonna do this number one together? Yeah? Okay. So first, 45 degrees north of west. Which direction is that? Do you remember? Never eat soggy waffles. Okay.
Is north of west northwest?
Yes.
Oh.
So 45 degrees. Let's see. So this is going to be 45 degrees. And for 1,000 feet. Then 200 feet north. So that's 200 feet straight up. How far and at what north of west quadrant bearing is Emma from her apartment? Okay. So the resultant vector is going to be this right here. Yes. North of west. Here's west.
Is it from the
So if she was south of west, it would be in the third quadrant. Yeah. Okay, so what I need to do is I need to break each into its x and y components. So here's 45. So I have a 45, 45 triangle. All right, the hypotenuse is 1,000. Do we remember 45, 45, 90 triangles? What are the sides? Leg, 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 root 2. Right, leg, leg, and then leg root 2 is the hypotenuse. So if 1,000 is equal to root 2 times leg, literally the leg is going to be 1,000 over root 2, which is 500 root 2. Okay, so to find the x resultant, you add the two x values together. Well, there's only one x value, and that's from the 1,000 feet walking. So that's going to be 500 root 2. Versus the resultant in the y, we have 500 root 2, and then we also have 200 more feet going up. Which part? Well, we're trying to find the resultant vector, right? So what I'm trying to do is take each vector component, break it into its rectangular components, right? X and Y, X and Y. Add all your X's together, that's your resultant X. Add all your Y's together, that's your resultant Y. Yeah. Maybe the way I'm writing it is confusing. Do I want to just upload the solutions? But I was less nasty drawing it now. Okay. Well, that actually does not. That's not helpful. That's not helpful. It's probably more. Okay, that's more confusing. Got it. Huh? Yep. I did warn you guys. Vectors was a little challenging. Okay.
I just don't understand. Like, I see you doing it, I just don't understand how.
Okay, so the first vector, the 45 degrees north of west, right? So let me draw this out here. So 45 degrees north of west. So I'm starting here. I'm going 45 degrees. That's my bearing. Well, it's the same thing as having the 45 degree here. Okay, so I have this triangle. Right, this is my first triangle. So she's walking 1,000 feet at an angle of 45 degrees. So how far did she go horizontally? How far did she go vertically? We know that. We found the two components. Trying to think of a better, what? What's your question? So ready? She walked this way and then she went that way. Then she went this way. So I want to know, okay, well, if I was a bird and I could fly straight across, what would the resultant be? If I was a bird and I could just fly straight there without the shenanigans of having to turn on a street, what would the resultant be? So in order to figure that out, all of her horizontal distance is from the first 45 degrees she was walking. But she was walking 45 degrees, so there's some vertical addition as well with this 45-90 triangle. Then she has a vector that's straight up. There's no horizontal, it's all vertical. So all of the horizontals from the first part, the vertical, there's some vertical from the first, and the rest, the whole second vector is all vertical. So I'm trying to find how far and at what northwest. Okay, so what I'd like to do is I have this triangle now. This is my resultant vector. Does my hypotenuse look similar to the one over here, right? This hypotenuse, this resultant vector. Okay, I need to solve for this length. In order to solve for this length, I'm like, okay, all my horizontal component is coming from this first vector that's the 45 degrees. But my vertical component of my resultant vector, part of it comes from the first part of her walk, part of it comes from the second part of her walk. So I'm adding all the horizontal components. The only horizontal is from the first vector, which is 500 root 2. Now, her vertical component, part of it is from her first part of her walk, part of it is from the second part. So I have to add this vertical component plus the vertical from this component. Okay, now I'm making a triangle because guess what? If I have one side and another side, I can solve for the hypotenuse using Pythagorean theorem. Once I know this length, I can solve for the angle. Yeah. Okay, it's okay. Step by step, we'll get through this together. Yes?
I'm just confused on why you put the 1,000 feet.
Because that's 45, ready? She walks 45 degrees north of west for 1,000 feet. So she walks 1,000 feet, but at an angle of 45 degrees. So what part of that 1,000 was horizontal? What part of that 1,000 was vertical? So I drew a triangle. So that's what this is showing you right here, is you have this 1,000 feet, but part of it is purely horizontal, part of it's purely vertical. Okay.
That little triangle is just a little quadrant section.
It's just, this right here is only the first vector. Because I had to break that first vector into its components.
So from like the initial triangle, it's just the bottom part of it? Does that make sense? Like,
For the horizontal is only the bottom part.
Oh.
Yeah. Okay, so here, this is 500 root 2. And this vertical, 500 root 2 plus 200. 500 root 2 is going to be 707. What is it? What's 500 root 2? No one with a calculator? 500 root 2?
707.
707.11, right? So 0.1068.1. Okay, if I add 200 to that, that's 907.11. I have two lengths. In order to solve for the magnitude of my resultant, I have to use Pythagorean theorem. 707.11 squared plus 907.11 squared. And then I have to take the square root of that in order to get my resultant. Is it 1,000? What is it? 1,115?
150.1.
Okay. So now that we know what angle this is at, 1,150.15 feet, we have the length, right? We have the magnitude. Awesome. How far? She is now exactly 1,150.1 feet from her apartment, but at what angle? We must have a direction. Yes.
Why wouldn't it be negative 707.8?
Well, when you square the negative, it goes away. When you square the negative, it goes away. So, so it's,
in the triangle itself, because it's on.
yeah, so this is negative, so this is negative, so this is negative, but the negative squared goes away. Yeah. Because we're technically in the second quadrant. Yeah. But the direction, like, the negative indicates direction here, right? The negative indicates we're going left. Yeah. Okay. We need to find the quadrant bearing. I would like to know, what is this angle right here? How would I find that angle? Inverse. Which would you like to do? Which one? Tan. Okay, so tan of theta, tangent is opposite over adjacent, so 900 and...
Did you not have to find the distance?
We did, because it said how far. How far was the 1,150? So at the end, I was going to like put it all together. All right, so tan inverse theta is tan inverse of 907.11 over negative 707.11. So remember tan inverse, it's from negative pi over 2 to pi over 2. So it's only giving me the answer between the first and fourth quadrant. So give me an answer in the fourth quadrant, but I want an answer in the second quadrant. So how do I get the angle? Do we know? Nope. Okay, let me show you. Let's draw a picture. Yeah, these are easier problems in the book, so worksheets it is. Okay, so we got the angle that is 52.06 below the origin. Now, there's another place that tangent would have like the same value, right? The one that second quadrant. Okay, so what do I need to do to get to the second quadrant? Yeah, I could add 180. So if I add 180 degrees, that would get me the angle in the second quadrant. All right, it would tell me what angle this is. Going around. So I add 180, so it's 130, 127.94. Yeah. But that's measuring from standard position. Right, from standard position, it's 127.94. We want from north, right? We want a north of west. So we minus 90. That way we have this whole angle. Okay, let me show you what this is. So I want this angle. I was given the overall angle. So if I subtract 90 from this, it would give me what the north of west quadrant bearing was. 37.94 degrees north of west. This is the direction, this is the distance. So the hard part is thinking back to chapter 4. Understanding. How can I get into my second quadrant if I'm given tan inverse in my fourth quadrant? All right, questions before we go to the next one? So number 2 is just like one of the problems in your notes. So we can go on to the next one. Let's go to number 3. So number 2 is just like the ones in your notes, right? It's just like the one in your notes. We're cool on number 2. Number 3 is, okay, a little harder. An airplane with an airspeed 500 miles per hour is heading due north. Okay. Due north is which direction? Straight up. So this is 500 miles per hour. If a 50 mile per hour wind is blowing at a bearing 270 degrees. Okay. So 270 degrees is which direction?
You start from
so I meant to go to your notes. Hold on. Where's your notes? So true bearing starts from north. Your bearing, let's see, true bearing starts from north. Bearing, what I meant to write on this problem because it was vague. Oh no, my bad. What I meant to write on this problem, is at 270 degrees measured from standard position. Because what I wanted you to do was draw your 50 miles per hour going down. And then if you determine the velocity and speed of the plane relative to the ground, so although you're burning enough fuel, you should be going 500 miles per hour, the wind is taking away some of your velocity. So if you add these together, what do you get? 270 degrees from standard position. 270 degrees is 3/4 of the way around, so it's going down. That's what I meant to write. So yeah, 500 plus, and then 50 is going down, so negative 50 is going to be 450 miles per hour. And the direction is going to be north. 500 miles per hour going north. And a wind is blowing 270 degrees from standard position, so it's ready 270, 90, 180, 270 is going down. So something going up, something going down. Literally 50 is going the opposite direction, so it's 450 miles per hour north as your resultant. Right. Did you guys want to try number 2? I mean, or go on to number 4? 4? Okay. Are you okay over there? Alright, I just hear a lot of like noises. I'm worried. Okay, cool. Okay. So the trick here, ready for this one? You pull out 2 triangles. Here's my first triangle, 20 degrees, and this is 2,000 newtons. And you must break it into components, right? Your force in the y for your first triangle, force in the x for your first triangle. And then I have my second triangle. All right, this is 1,500 newtons. This is also 20 degrees, so here's my force for my second triangle, force in the y for my second triangle. So you have to break them both into components. What is the sum? So once you find the horizontal for both, you add them, that's the sum. Once you find the vertical component of both triangles, you add them, that's it. The resultant force, it's like the problem we, the first problem we did, where you have your resultant x, you have your resultant y, now draw a triangle and do your actual hypotenuse of your resultant. Okay, so this is, well, okay, we could do some of it. We only have like 2 minutes left of class, so 1 minute left of class. Do you want to keep going or pack up? All right, think about how you would find the horizontal. So for this green one, the horizontal is going to be adjacent. So cosine of 20 degrees is going to be, let's see, adjacent over hypotenuse, so f of x2 over 1500. So you take hypotenuse times cosine 20 degrees. To find the y value for the green one, right? The y is going to be 1500 times sine of 20 degrees. Because sine of 20 degrees is going to be f of y2, right? Opposite over hypotenuse, which is 1500. Rearrange. So I don't have my calculator with me, but similarly with the pink over on the right side, right? The adjacent side of my 20 degrees is my y. So I have 2000 times sine of 20 degrees. That's going to be fy1. fx1 is going to be 2000 times cosine 20. And then once you find all four of these numbers, you add them together, and that will give you your degree. All right, just a moment. Okay. All right, so very important, one last thing. This should be, the 20 degrees is going down, so if you put in negative 20 degrees, it will give you a negative y value. Because this y should be going down, and that's what we'll stop for today.